Bismillahirrahmanirrahim. In this video, inshallah, I'll try to explain you that what is trigonometry, and I'll also explain you that how trigonometry is applied in our daily life. I think so you might be aware of Pythagoras theorem. You know that Pythagoras theorem is the theorem which is applied on right angle triangle, and with the help of the Pythagoras theorem you can find out the missing sides of a right angled triangle. Only the right angled triangle you can find out the missing sides of the right angle triangle if the two sides are given. You know that in a triangle there are three sides. If any of the two sides of the right angled triangle are given, then you can find out the third side of the right angle triangle with the help of the Pythagoras theorem. So keep in your mind, you cannot find out angles with the help of the Pythagoras theorem. Okay. Now as far the trigonometry is concerned, with the help of the trigonometry we can not only find out the sides of a triangle, we can also find out the angles of a triangle. And here in the case of the trigonometry, we can find out the sides and angles of any type of a triangle, whether it is a right angle triangle or it is not a right angle triangle. So whatever the type of the triangle is, we can solve that triangle with the help of trigonometry. Okay. Now in trigonometry, first of all, I am going to explain you that what are trigonometric ratios. Okay. Now as from the name it is clear that these are the ratios. So what type of ratios these are? Basically trigonometric ratios are the ratios between the sides of a right angled triangle. Here I am taking a right angle triangle. So keep in your mind that whenever I am talking about the trigonometric ratios, so these are the ratios between the sides of a right angled triangle. Here I am taking a right angle triangle PQH. Here H is the right angle. Okay. So keep in your mind that H is the right angle. Well, now capital PQH are representing the vertices of the right angle triangle, and small p, q and h, these are representing the sides, okay, sides of the right angle triangle. So keep in your mind that whenever I am using the capital P, capital Q or capital H, so these are representing the angles of the right angle triangle, and small p, q, h are representing the measure of the sides of the right angled triangle. Another very important thing which you must keep in your mind, that the definition of the trigonometric ratios only applied on the acute angles of the right angled triangle. Here in this right angled triangle, angle P and angle Q, these two are the acute angles of this right angle triangle, and this is the right angle, mean the angle of 90 degree. So this is the 90-degree angle which is called right angle triangle, and rest of the two angles are acute angles. So whenever we are talking about the trigonometric ratios, then we will take the reference of either angle P or angle Q. Now how we are going to apply this? Okay. Now here you can see that I have written hypotenuse, adjacent and opposite. What does it mean? I am going to explain. Now here you can see that I have written hypotenuse, opposite and adjacent. As you know then that in the Pythagoras theorem, the side opposite to the 90 degree is called hypotenuse. We are not going to change the name of this side which is called hypotenuse, and this is the 90-degree angle. As you know that in the right angle triangle, the 90-degree angle is the greatest angle, and the rest of the two angles are the acute angles, mean these two angles are less than 90 degree, and the sides opposite to the rest of the two angles, two acute angles, will be shorter than the hypotenuse. So hypotenuse will be the longest side of the right angled triangle. This must also be kept in your mind while solving the sides of the right angle triangle. Okay. Now why I have written opposite here? Now if I am going to write down the trigonometric ratios with reference to angle Q, if I am going to write down the trigonometric ratios with reference to angle Q, then opposite to Q, opposite to angle Q is called opposite. Okay. Now we will also consider the trigonometric ratios with reference to the second acute angle P also, but first of all I am taking this angle Q. I'll also tell you that if I am considering angle P, then how we are going to name that. Okay. So against this angle Q, because I am considering at this time angle Q. So opposite to angle Q is called opposite. There is another name for this, or we can also say this side as perpendicular. We will also say this as perpendicular, like in case of Pythagoras theorem. Okay. Now the side adjacent to Q, as you know that at the sides adjacent to Q, there are two sides adjacent to Q. One is the hypotenuse, and the rest of the side is named as adjacent, or it is called base, like you have named it in the Pythagoras theorem. So keep in your mind, I am taking angle Q. So with reference to angle Q, I am going to write down the names of the trigonometric ratios. So if I am taking the ratio between opposite and hypotenuse, or perpendicular to hypotenuse, so the order must be kept in your mind, that which side is taken as numerator and which side is taken as denominator. It is very important to keep in your mind the order of the numerator and denominator. So perpendicular is taken as numerator, and as a denominator we are taking as hypotenuse. So ratio between perpendicular and hypotenuse is called sine of this angle. It is written sine, but we say the sine of angle Q. This angle is Q, so I am writing this degree sign. So sine of angle Q is the ratio between perpendicular and hypotenuse. This order does matter, keep in your mind. So this is the first trigonometric ratios which I have told you. Okay, sine angle Q is called perpendicular over hypotenuse. Now if I am taking the ratio between base and hypotenuse, or adjacent over hypotenuse, we can also write it like opposite over hypotenuse. Opposite over hypotenuse. Whether you can take name as opposite over hypotenuse or perpendicular over hypotenuse, whatever you can say, it's okay. Now if I am saying that adjacent over hypotenuse, adjacent over hypotenuse is equal to, or you can also say, some people say that base over hypotenuse, base over hypotenuse, whatever the name you can say these sides, adjacent or base, opposite or perpendicular, it's up to you. Okay, so here it is called this, the name of this ratio is called cos of angle Q, because we are considering angle Q at this time, we are considering angle Q. Okay, now the third ratio, if I am going to take the ratio of opposite over adjacent, opposite over adjacent, or we can also say as perpendicular over base. So perpendicular over base or opposite over adjacent, this is called tan of Q, tangent. Okay, so these are the ratios with reference to Q. Whether you can learn these or you can learn these, whatever you find easier, you can apply. So here I am going to use these names like perpendicular over hypotenuse, base over hypotenuse, perpendicular over base. Okay, so I am applying only these names, I am using these names. So with reference to these names, I'll solve the sums. So now I have taken angle Q and I have written all the trigonometric ratios with the reference of angle Q. Now if somebody asks you that what is the side perpendicular, so measure of the side perpendicular I am taking here as small q. Small q is the measure of side PQ. So you can also write that sine Q is equal to, sine of angle Q is equal to side Q over hypotenuse. Or in the same way, you can say that cos is the ratio between base and hypotenuse. So for this Q, the base is P, P is the base and H is the hypotenuse. In the same way, tangent Q is the perpendicular over base. So perpendicular here is the Q and the base is P. So in this way you can write down the sides of the given triangle. If instead of P, Q and H, the measurement of the sides may also be given, and instead of this Q or P, the values of these angles may also be given. Okay. Now with reference to the same triangle, if I am considering the angle P, previously I was considering the angle Q, so this side was opposite or perpendicular and this side was called adjacent or base. Now here I have drawn again the same triangle, you can see. Now this angle, I am going to consider this angle P, okay. So against the 90-degree angle, there is hypotenuse, this side will not be changed. So keep in your mind, against the 90-degree angle, there is hypotenuse. Now if we are considering angle P, so opposite to P will become opposite or perpendicular, okay. Now we are considering this angle, so opposite to this angle, the side will be called opposite. Now adjacent to this side is called adjacent to this angle is called adjacent or base. Now you can see that the names have interchanged. These two names have interchanged. Previously that was opposite, now this is opposite, because we are considering this angle. Previously we were considering this angle, so side opposite to this angle is called opposite. Now we are considering this angle P, so side opposite to P is called opposite, and the side adjacent to P is called adjacent or base. Now again I am going to write down the trigonometric ratios with reference to this changed side. Now what will you write? That if you are going to write down sine P, as I told you, sine P is the perpendicular over hypotenuse. Now which side is perpendicular? This side is perpendicular. This is angle P. This side, small p, is representing the measure of side P. So this is P over perpendicular hypotenuse, hypotenuse is H. In the same way, if you are going to write down cos P, cos is the ratio of base over hypotenuse. So now here base is this side. Previously base was that side because you are considering angle Q. Now you are considering angle P. So the base is this. The base is Q. Q over hypotenuse H. Okay. Base over hypotenuse. Now tan P is equal to perpendicular over base. So this side is perpendicular and this side is base. So this is P over Q. Now you can see that how by changing the angle and under consideration we can interchange these two sides. So okay, I think so this is clear. You can watch it again to make this clear to you. Okay, so these are the basics of the trigonometric ratios. Now we will try to solve some problems with the help of these trigonometric ratios. Now let us consider this problem related to trigonometry. We have to write down the trigonometric ratios. So first of all, I am going to write down the given sides in the form of the trigonometric ratios. For example, if you are asked to write down the ratio sine of angle A, angle B and angle C. Angle C is the right angle, so against the right angle there is hypotenuse. So for the sake of convenience, I am writing the names. This is called hypotenuse, and I told you that if you are considering this angle A, then opposite to angles A will be perpendicular and adjacent to angle A is called base. So this side will become base, that will be the perpendicular. So opposite side to the angle under consideration, because I am going to write down sine of angle A. So that side, B to C side, so this CB side which is of 3 centimeter, this will be called perpendicular. So as I told you that sine is the ratio of perpendicular over hypotenuse. So here the perpendicular is 3 centimeter, mean the side C to B, which is 3 centimeter over hypotenuse. Hypotenuse is the side 5 centimeter. Okay. So this will be the ratio for sine A. Now in the same way, if you are required to write down cos of angle A, then cos is the ratio between base over hypotenuse. So cos is the ratio between base over hypotenuse. So here base is 4 and hypotenuse is 5. So this is 4 over 5. In the same way, if somebody asks you to write down the tangent of angle A, tangent is the ratio of perpendicular over base, perpendicular over base. So the perpendicular in this case is 3 and the base is 4. So here are the three trigonometric ratios. Now, if you are required to find out the measure of angle A, what you can do? When all these three sides are given, then to find out angle A, you can use any of this trigonometric ratio. Okay? If all the three sides are given, I told you that if all perpendicular, base and hypotenuse are given, then to find out the angle A, you can use either of these ratios, sine ratio, cos ratio or tangent ratio. Now, how we can find out angle A? Now, with the help of these trigonometric ratios, you can also find out the angle A or angle B. Now, you can see that in this right angle triangle, all the three sides are given. Okay, 1 is 3, 4 and 5. These three sides are given. When all the three sides are given, you can use either of these trigonometric ratio. Whether you can use sine A or cos A or tan A, same answer will come if you are using either of these three ratios. So if I am using sine A, for example, if I use sine A, sine of angle A, which is equal to 3 over 5. 3 over 5. Now what you are going to do? You will have to shift sine to the other side. Whenever sine goes to the other side, it becomes sine inverse. We will write it like this, sine raised to power minus 1, which is called sine inverse. Okay. Now in the bracket, you are going to write down 3 over 5. Now with the help of the calculator, you can find out the value of sine inverse 3 over 5. What you are going to do? You will have to press the shift function and then you will have to write down the sine. Now you can see that on the calculator it has appeared sine inverse. Now in the bracket you can directly write 3 divided by 5, bracket close, like this. So this is 36.869. So in two decimal place we can write it as 36.87 degree or 36.9 degree can also be written. So in this way, either of these cos or tangent you can apply to find out this angle. And when this triangle, if angle A is known to you, so you can also find out angle B. Angle B can also be found out with the same trigonometric ratios. As I told you that if you will consider angle B, then this side will become perpendicular and this side will become base, and you can apply these trigonometric ratios. Now in this particular question, if I have already calculated this angle A, so angle B can be calculated by subtracting angle A from 90 degree. So angle B can be calculated like 90 minus 36.87. So subtract this from 90. So 90 minus 36.87 is equal to 53.13. So our answer will be 53.13, or simply you can write 53 degree. Okay. So in this way you can calculate the missing angles also with the help of the trigonometric ratios. Now in this question you can see that this is the right angle triangle in which one angle is 72 degree and this hypotenuse is given against the 90 degrees angle. The side is hypotenuse. We have to find out the side x and y and the angle. Find the sides x and y and the angle q. It is very simple to find out the angle q. You can just simply find out angle q like angle Q is equal to 90 degree minus 72 degree. So from 90 degree you will have to subtract 72. So what your answer get? 10 minus 2, 8. So you got answer 18 degree. It is very simple to find out the remaining angle. Now to find out the side X or Y. Now here you can see that both the sides are not known to you. You might be thinking of applying Pythagoras theorem. As I told you that in the case of Pythagoras theorem, any two sides must be given. Any two sides of the right angle triangle must be given. But here we have only one side of the right angle triangle. So we cannot apply the Pythagoras theorem here. Okay. So first of all, we can find out side X or side Y by using the trigonometric ratios. And when we will be getting the other side also, then you can either apply the trigonometric ratios or you can apply the Pythagoras theorem. It will be your choice then. But here now you cannot apply Pythagoras theorem. Now I am considering angle P. If I am considering angle P, then against this angle P will called perpendicular. Okay, and this side will be the base side. This perpendicular or opposite and adjacent or base, and this side is called hypotenuse. Okay. Now, as I have to find out side X, first of all I am going to find out side X. So side X is perpendicular and the known side is hypotenuse. So perpendicular or hypotenuse is called sine of angle P. Now why I am not using the side Y? Because side Y is also unknown. This side is also unknown. How I can find out these two unknown sides from the same trigonometric ratios? Because there are three things out of which two must be known to us. Now here we know this hypotenuse and we don't know X, we know this angle. So out of these three things, one is missing, so we can apply the sine ratio. Sine ratio is perpendicular over hypotenuse. So sine of angle 72 degree is equal to perpendicular over hypotenuse. Perpendicular over hypotenuse. Now here in this case, the perpendicular is X and the hypotenuse is 12, and here is sine 72 degree. Now what I am going to do? I will have to apply this 12 to the other side. So X is equal to 12 into sine of 72 degree. Now with the help of the calculator, we can find out the value of this. What you are going to do? First of all, I am going to press 12 and then pressing sine, directly sine, not inverse. Here I am not going to take the inverse. Sine of 72 degree. You may close the bracket and then you will have to press equality sign and you will get 11.41. 11.41 centimeter, or you can also write 11.4 simply. Now unit is very important because here you can see that the side is given in centimeter. So here I will have to write down cm. In the same way, you can also find out the side Y. Here, because I am considering angle P, so this will be the base. So base over hypotenuse. This is called cos ratio. So I can apply cos of 72 degree is equal to base over hypotenuse or adjacent over hypotenuse. So here base is Y and the hypotenuse is 12. Now again you are going to do the same thing. 12 will multiply to this side. So Y is equal to 12 into cos 72 degree. Okay. Again I am going to apply the calculator. Now in the calculator, first of all write 12 into cos of 72. Closing the bracket and then pressing equality sign. 3.72. 3.71. This is equal to 3.71 degree or simply 3.7 centimeter. So here you can see that this side, which is called the perpendicular, which is 11.4 centimeter, and this base, which is 3.7 centimeter. These two sides are shorter than the hypotenuse. As I told you that in the case of the triangles, the against the largest angle there will be the largest side. Now here this angle was only 18 degree, this angle 18 degree, against the 18 degree the shorter side base, which is 3.7 only, and against 72 degree the 11.4, and against 90 degree it is 12 centimeter. So whenever you are solving it, you must also consider that how your sides are dividing, how your sides are coming.